Hi guys, welcome back. Today's lesson is going to introduce another method for solving quadratic equations. Up till now we've already learned two different methods. We can solve quadratic equations by factoring, we can solve quadratic equations by completing the square, and now we're going to learn how to solve quadratic equations using the quadratic formula. The advantage of today's lesson is the quadratic formula always works. Factoring is not always going to work. Not every equation can be factored. Completing the square is not always convenient. Sometimes it can be a very difficult problem to complete the square. Quadratic formula, it seems somewhat difficult in the beginning, but eventually you get used to it and it's always going to work. So it's a convenient one. If there's one you're going to learn, this is the one. So before we get started, I just want to go over some easy problems so that we can look at the types of answers you get for a quadratic equation. So the first one, hopefully you know by now that there's two answers to this. When you think what number squared is 25, there's two of them, 5 and negative 5. The work we show on that, if you want to show work, because you don't have to for this type of problem, square root both sides and x equals both positive and negative 5. So again, often for a quadratic equation you get two answers. Okay, now look at the second one. This one, what number can I square and get a negative? Nothing. There's nothing that will work there. When you show your work for that, I want you to pay attention to what that looks like because it's still going to happen when we do the quadratic formula. When you square root both sides, you cannot take the square root of a negative number. So we say no solution. That's still going to happen when we do the quadratic formula today. If ever there's a negative number underneath the radical, you got to know that means no solution. And you get to stop right then and there and not go any further. Okay, the next one is what it looked like in the middle of the problem when we were completing the square. This is already a completed square. So I can undo the square by square rooting both sides. And then you get x plus 3 equals plus or minus the square root of 16. So plus or minus 4. Subtract 3 on both sides, and we get two answers. X equals negative 3 plus or minus 4, and those are like terms. I can add and subtract negative 3 and 4, so I'm going to simplify that further. Negative 3 plus 4 would give me the answer of 1, and negative 3 minus 4 would give me the answer of negative 7. So again, so far we have the number of solutions we've gotten. The first example had two solutions, 5 and negative 5. The second one had no solutions. The third one also had two solutions. So the question I'm trying to get at here, is it possible for there to only be one solution? So let's see. Treat this last one just like we did the third. We're in square root. Take the square root of both sides. The square and square root cancel each other out. So x minus 5 equals plus or minus the square root of 0. But what is the square root of 0? What number squared will give you 0? And there's only one answer to that. There is no such thing as a positive 0 and a negative 0. 0 is the only number that has no sign. It's neither positive or negative. So x minus 5 is equal to just 0, no more plus or minus there. Get x by itself, add 5 to both sides, and x equals just 5. You don't have two answers. So it is possible to get one answer, but that's really only going to happen when you have the square. Hold on, got lost there. Give me a second. Pause. I still have technical difficulties every time I hit the wrong button with my hand. Anyway, the only time you're going to get one answer is when you have the square root of 0. And that will come up within the quadratic formula too. I'm just sort of kind of hinting at it right now, and what it means is going to come up more and more. All right, so we're going to move on to actually solving with the quadratic formula. This crazy looking thing is the quadratic formula. And usually I would say you have to memorize it, but since You will eventually have to memorize it. But for right now, you can put everything in front of you. You can have your notes in front of you, so you don't really need to memorize it. I do have a song for it. I cannot sing on a video. I refuse. But hopefully I'll see you in person one day and I will sing this stupid song for you and it'll stick in my head all day long and hopefully yours too. It'll help. But when I see you in the future, make me sing this song to you, even though I really don't want to. Moving on, past that. Okay, the quadratic formula. If you're given an equation in standard form, it's a quadratic equation. Quadratic means it has that square, okay? And standard form means you have the squared term first, then the x to the first, then the constant set equal to 0. It has to have a 0 on the right side. If you have that, then the solution or your answer for x will be negative b, where b is the number in front of the x term, plus or minus the square root of b squared minus 4ac. A is the number in front of the x squared. C is the constant, all over 2a. Now, it looks crazy, I know. Just hang in there. Be calm. Deep breath. Be calm. It's not that bad. I'll show you how it works with the next problem. And you'll see you get used to it pretty quickly. Okay, so here's a problem that I intentionally chose because it's actually factorable. So the quickest way to solve this problem, by far, is to factor it. And that might make you say, well, then why the heck are you teaching me this new method? Again, not every problem can be factored. So real quick, let me show it to you factored. The reason this one is easier to factor is, as you can tell, that quadratic formula is a good bit of work. So always check, can you factor? In this case, can I find two numbers that multiply to a negative 63 and add to a positive 2? Okay, and that would be positive 9 and negative 7. And when you set each of those factors equal to 0, you get negative 9 and positive 7 as your two solutions. That is going to be by far the quickest way to solve that problem. Okay? Now, we're going to get those same two answers using the quadratic formula. In fact, this problem also could have been done by completing the square. I could have moved the 63 over to the other side and I could have completed the square. Okay, but that's not today's lesson, so now let me show you. We should still get those same two answers. We should still get negative 9 and 7, but we're going to do it using the quadratic formula. Okay, so let's just make a note. Our answers were negative 9 and 7. We better get those same two answers. All right, here we go. First, we have to figure out what is a, b, and c. A is the number in front of the x squared. So in this case, a is 1. And you don't have to write this down. You can just take it right off the equation. B is the number in front of the x. So in this case, b is positive 2. C is the constant term, which would be negative 63. Now we're going to apply that using this big formula right here, which you'll get used to. The solution, x, will equal negative b. Okay, it says negative b. Well, if b is 2, then negative b would be negative 2. Some people say instead of negative b, they'll say opposite of b. Okay, so if b was 2, then negative b is going to be negative 2 plus or minus big fat square root right there, big old square root. Underneath that square root, we have b squared, so that's 2 squared, or 4, minus 4 times a and times c, because if they're squished together, that means multiplying. So 4 times a, which was 1, and c, which is negative 63. Next, there's this big fraction bar. So the fraction bar goes all the way over to the beginning. So all over, this says 2 times a, and a is 1. Now, oops, let me close that parenthesis I see right there. You don't actually have to show every single step. Like 2 times 1, you could have obviously just done that in your head. Okay, but that's me just applying this formula. Right, now you just have to simplify it. That's the nice thing about the quadratic formula. You don't have to think that much. You just have to do it. You got to do what it says to do. So x is going to equal, I just got to simplify this, -2 plus or minus the square root of. I'm going to be using a calculator for this anyway. Because 63 times 4, yeah, I can do it, but I don't really want to. So I would suggest you put all of this in your calculator at one time, all in order. 4 minus 4 times 1 times -63. And again, you don't need to put the 1 in there. So, in my calculator all at once, 4 minus 4 times 1 times -63. And all of that equals a positive 256. Okay? The other option is to just multiply these 3 numbers and then do 4 plus that. It's totally up to you. Okay, you'll get used to it. All over 2 times 1, which is 2. Okay, so that 256, remember, I put all of this in my calculator at one time. Just the way it looks. Okay, now square root of 256. Let's see if that is a nice, neat number. Put the square root of 256 in your calculator. And look at that. It's a whole number, 16. So now I have -2 plus or minus the square root of 256 is 16, no longer has a square root because I could take the square root, all over 2. Okay, focusing just on the numerator, this is 2 numbers that are like terms. You're just going to add 16 and subtract 16. So -2 plus 16 would be 14, but this 2 is still here. And then -2 minus 16 would be -18, and this 2 is still there. Now, see if you can simplify that further. 14 over 2, well, that's the same as 7. -18 over 2, that's the same as -9. So those are my 2 answers for x, which, look back at what we said at the beginning, factoring was a lot quicker, but yes, it does work. So this kind of makes the point very clear. If something is factorable, you don't want to use the quadratic formula. But the quadratic formula can be used when things aren't factorable. Now, let's do another example. Hit pause, maybe rewind and watch that again because it's not really going to change from problem to problem. The only thing that changes from problem to problem is how you simplify this answer right here. Okay? Okay, problem 2. Let's try it again. You guys know it's always hard the first time you do a problem. The first day of every lesson we ever do is always, you guys always get very frustrated. I get it. It looks really complicated. But I promise you, you will get used to this, just like you've gotten used to everything else. All right, now this problem is not factorable. I can't find 2 numbers that would multiply to a -22 and add to a +3. So this is not factorable. I could actually complete the square by taking the 22 and moving it to the other side, but then I would have to do half of 3 squared, and it just gets really messy and kind of ugly. So that's also not convenient. So this is a perfect case for quadratic formula. Now, here we go. First, find your A, B, and your C. You don't have to write them down, but I'm going to do it for you anyway. A is the coefficient in front of the x squared term, so A is 1. B is the coefficient in front of the x term, so B is +3. And C is the constant, so C is -22. Applying this formula, x equals -b would be -3, plus or minus the square root of b squared, square it in your head, 3 times 3, which is 9, minus 4 times A, don't really need to write it if it's a 1, times C, -22. All over 2 times A, so 2 times 1, which is 2. Okay, that is just like it was in the last problem. Simplify it. Bring down the -3 plus or minus the square root of. Put all of this into your calculator at one time. Okay, so 9. Make sure you've done the squaring in your head because you don't want to have like a negative number there. That first number should always be positive because it was squared. All right, so 9 minus 4 times 1, if you want to write it, times negative 22 is 97. So there's still a 97 underneath my radical, and then all over that 2. Now, for this one, the square root of 97, let me put that into my calculator. That is not a nice, neat number, and I can't come up with two numbers I can multiply together to get 97 where I could break one of them down. So that's it. I'm done right there. That's the end. Okay, here we go. This one does not look very pleasant if I was going to try to factor it, but it's possible, it's factorable. I could multiply everything by -1, so the first term was negative, but we're going to use quadratic formula anyway. The quadratic formula always works. All right, so find A, B, and C. A is the coefficient in front of the square term, so A is -3. B is the coefficient in front of the linear term, that's what they call that, so B is -5, and C is the constant, so C is +8. Apply the formula, X equals, or in this case it would be P equals, I don't know why I did that to you, but no big deal. Negative B, if B is -5, then negative B is 5, plus or minus the square root of B squared. Well, if B is -5 times -5 is +25. Always write a positive number there. Minus 4 times A times C. 4 times A, which is -3, times C, which is 8. All over 2 times A. All right, now just simplify it. Bring down the 5. This is what P equals. 5 plus or minus the square root of. Put all of this into your calculator in the order that you see it. 25 minus 4 times, and you can use parentheses even, 4 times -3 times 8. And I get all of that to be 121. And on the bottom, 2 times -3 is -6. Okay, simplify. The square root of 121 is a whole number. The square root of 121 is exactly 11. So we now have that P equals 5 plus or minus 11. No radical because I took the square root of 121 and I get 11. All over -6. In the numerator, add and subtract. 5 plus 11 would be 16 over -6. And 5 minus 11 would be -6 over -6. Now simplify these two things. 16 over -6. Remember, 2 negatives would make a positive. 1 negative is a negative. And this means divide. And 16 doesn't divide by 6 evenly. So leave it a fraction. I have 1 negative, so my answer is negative. And I can leave it 16/6, except I should simplify it. 16 and 6 can both be divided by 2. Divide them both by 2 and you get -8/3. You don't typically put this negative on the top or the bottom. Usually if there's one negative, you just write the answer is negative and you just put this negative kind of like right out in front of the middle of the fraction bar. Okay? The other one, -6 divided by -6, is a +1. So I have two answers, -8/3 and a +1. So if you look back on this problem, the only thing that was different, the setup was all the same. From here, it was still the same, just had to add and subtract 11. The difference was you just had to simplify the fraction at the end. Okay, last one. Okay, so starting off the same. Figure out what your A, B, and C are. So A is the coefficient in front of the, oops, sorry about that. Okay. A is the coefficient in front of the squared term, so A is going to be 9. B is the coefficient in front of the linear term, so B is 5. And C is the constant, so C is positive 11. Okay, now apply the formula. X equals is normally what we say, but we have an R, so R equals negative B. If B is 5, then negative B is negative 5 plus or minus the square root of B squared. If B is 5 and B squared is 25, minus 4 times A times C. 4 times A times C, all over 2 times A. All over 2 times A. You can write 2 times 9, or you can just write down what 2 times 9 is, 18. Same thing. Okay, now simplify it. R is going to equal negative 5 plus or minus the square root of. Put all of that into your calculator. Everything under the radical all at one time. 25 minus 4 times 9 times 11. And I get negative 371. Now, bells and whistles should be going off right now. Yes, it's true I can write over 18 right here, but I don't even need to. Right now, I should stop, and I hope you know why. Underneath the radical, we have a negative number, and you can't take the square root of a negative number. So as soon as the number under the radical is negative, you stop, quit working, go, aha, I got an easy one. The answer is now no solution, because you can't take the square root of a negative number. All right, so that's it for now. I know this is not easy. Use your calculators, rewind the video, watch them again if you need to. I hope you guys are doing okay. Your assignment for today is just 6 problems, because I know it's time consuming. So today you should be doing week 3, worksheet 1. Good luck.